Okay, in this video, we're going to talk a little bit about what are called the coordinate axes, or the XY axes. And this is for the California Common Core State Standards, high school algebra, creating equations, standard A2. Okay, so what are coordinate axes? Remember that algebra is a language, and it's trying to translate what's happening to reality into symbols and variables and numbers that exist in the language called mathematics. Now, one of the tools that we have are called, where we can graph or translate some of this reality, is called the coordinate axes, or the XY axes. And basically, you've seen something that looks like this before, I'm pretty sure. So let's just talk a little bit about what that is. Now, you might recognize that this particular axis is just what's called a number line. And number lines are ways of describing reality, right? With this as being the 0 point. Here's 1, here's 2, here's 3, here's 4, here's 5. And a lot of times you'll see this. And then you'll see the same thing extend in the opposite direction. There's -1, -2, -3, -4, -5. And again, a lot of times you'll see these numbers, right? Now that's just the number line in one dimensions. Now, it's also sometimes called the x-axis. Now, a lot of people have taken this x-axis and then they flipped it up this way. And you have the exact same number line, but now it's going in a vertical axis. This is called a horizontal. And a lot of disciplines like physics, for example, call it the horizontal axis. Horizontal. And then the y-axis in mathematics is a lot of times called the vertical axis in different kinds of sciences, that sort of thing. And it works the exact same way. So again, if I took that and flipped it up, you'd have +1, +2, 3, 4, 5, and then -1, -2, 3, 4, -5. Okay? I'm not going to fill in all the numbers. You understand how that works. The reason that this has become very, very powerful in describing reality is because it's comparing two variables that exist in the real world. So for example, let's say you want to compare how fast a car is going over a certain amount of time. Okay, but the distance a car is traveling over a certain amount of time. Now notice, I had two variables that I talked about there. I have distance and I have time. And these are two variables. Now you could describe how fast a car is going over a certain amount of time, or excuse me, how far a car is going over a certain amount of time, just using regular words, right? But in mathematics, you have a little bit more precision in terms of how you can describe that. Now the x-axis, or the horizontal axis, is almost always the time axis. The y-axis, or the vertical axis, is always the other variable that you're comparing. So again, the coordinate axis is good for comparing or for describing two variables in reality. Okay? Again, those two variables almost always include time as one of your variables, and then some other quantity or something else in terms of the other variable. It's a very, very powerful way of predicting into the future or the past. Or describing the past, okay? Just by using reality on the XY axis. So for example, I could say something like, each of these particular numbers represents 1 hour. Okay, so I would just put down hour here. It could be seconds, it could be something else. And I could say the distance would be something like, let's say, miles. It could be inches, it could be whatever. And I could say something like this. After 1 hour, my car has traveled 2 miles. So at 1 hour, move 1 along the x-axis, it's gone 2 miles, go 2 along the y-axis. So the coordinate would be 1 hour, 2 miles, and there's the description of that car. Now, at the very, very beginning, when there has been no time, the car hasn't traveled 0 distance, so it's at 0, 0. Now what I can do is I can actually draw a line through that point. Let's just extend it down here. And I could ask myself the question, if the car's speed were steady, right? How many miles would the car travel after 2 hours? Well, here's how mathematics describes reality a little bit better and how it can predict the future. After 2 hours, I'll just follow this line and go right up here, and I see after 2 hours, it will have traveled, predicting 4 miles. Now, this is a prediction, right? Regular words can't do that. Mathematics can describe the reality, and that can do that, okay? So that's why mathematics is such an important language. It helps us predict the future events. It can compare a number of variables. By the way, if I wanted more than just 2 variables, I would just draw another axis, and we'll talk about that in other, that's way beyond our mathematics right now. We're only going to be comparing at the most 2 variables, okay? And you just probably should know some of these things in terms of vocabulary. All right, so anyway, that's why math is such an important language. I hope that was helpful to you.